Hello everyone, this is a recording for experiment number 6, multiplexer and demultiplexer. So the aim of our experiment here is to design and implement multiplexer and demultiplexer using logic gates and study of IC 74150 and IC 74154. So for the sake of simplicity, we are considering a 4 cross 1 multiplexer, and the combinational design of a 4 cross 1 multiplexer is explained here. So basically it has a total of 4 inputs, 2 selection lines and only one output. So according to our design, the input and output variables are a0, a1, a2 and a3, which are the inputs. The s0 and s1 are the selection lines, and y is our output. So this is the truth table for the inputs and outputs, and this is the logical expression based on the truth table. Let's just go on to the truth table once we go to the simulation part. So here is the circuit design for the multiplexer. So the components used here are 2 input switches, basically here the selection lines, 2 NOT gates, 4 AND gates and 1 OR gate. So let's move on to the simulation part. So as we could see, yeah, just a second. So now let's verify the truth table using the simulation that we had done for the multiplexer. So based on the selection lines, one of these outputs get activated, and as a result of which the bulb would glow. So when the selection lines are 0 0, as we could see, the output a0 gets activated. So this basically is a0. So when the selection lines are 0 and 1, that is when input of s1 is 0 and s0 is 1, we could see that this output is getting activated, and as a result of which the bulb glows. Similarly, when s1 is enabled and s0 is disabled, we could see that a2 is enabled or activated, and as a result of which the bulb glows. And finally, when both the inputs or both the selection lines are turned on, we could see that this output y gets activated, and as a result of which the bulb glows. So that's the simulation for multiplexer. Now let's move on to demultiplexer. So yeah, we are considering a 1 cross 4 demultiplexer, and the combinational design is explained using a block diagram. So in a 1 cross 4 demultiplexer, we totally have 4 outputs, 2 selection lines and only 1 input. That's basically the opposite of what we saw in multiplexer. So the input variables here are y0, y1, y2 and y3. The selection lines are s0 and s1, and a is our output. So here is the truth table which we'll be using for verification in the simulation. So the logical expression is this, which we obtained from the truth table, as we all know. So here is the circuit design. So our circuit here will consist of 3 input switches, 2 NOT gates, 4 AND gates. So now let's move on to the simulation part for better understanding. As we could see, the circuit design for a demultiplexer and a decoder almost is the same. So let's verify it using the truth table. So S0 and S1 are the input lines, input or the selection lines, based on which our outputs are gonna be turned on or activated. So when both the inputs are 0, we could see that Y0 is enabled. So this is Y0 according to our design. So when S1 is disabled and S0 is enabled, we could see that Y1 is enabled, and when S1 is enabled and S0 is disabled, that is when S1 is 1 and S0 is 0, we could see that Y2 is enabled, and finally when both S0 and S1 are enabled, we could see that Y3 is enabled. So that's a simulation for demultiplexer. Thank you.